Hello, good morning students. It's me Bipin Kumar Misra and today I have come to teach you classification of elements. In the previous classes, in class 8 also you might have studied about various types of elements. As you know that there are large number of elements. Some of them are metal, some are non-metal and some are metal-wise. So their properties are also quite different. Here, metals have the tendency of losing electron, non-metals have the tendency of gaining of electrons. Likewise, some of the elements exist in solid state, some exist in liquid state, and some in gaseous state. So, according to that, we can say that there are different categories of elements and their properties are also different. So, on the basis of their similarities and dissimilarities, elements are classified into different groups and periods. To make their study easier, to make the study of large number of elements easier, classification is done. So, we can say that classification is the systematic. It is a process of it is a systematic arrangement of elements into different groups and periods to make their study easier and more systematic, more scientific. Here, the first of all classification of element was done by Prout. First of all, Prout. Its classification was done in 1815 AD and he had arranged the elements in the increasing order of atomic weight of element. According to him, according to Prout, the atomic weight of the elements are the simple multiple of atomic weight of hydrogen. But this concept, the concept given by Prout is made to be wrong. It is because all the elements do not show such property. Then, after that, it was Davernier. Davernier in 1829. Davernier. Davernier in 1829 AD, he showed that if elements of a group, of a certain group, are taken in such a way that, just like suppose we take lithium, sodium, potassium. Atomic weight of lithium is 7. The atomic weight of potassium is 39.9. If the atomic weight arithmetic mean is taken to the atomic weight of these two elements, first upper and lower element, that will be the atomic weight of the middle element. If we take the arithmetic mean, just like 7 plus 39.9 by 2, this is equal to 23.4. This is the approximate atomic weight of sodium. Approximate atomic weight of sodium. In the same way, we can take the example of chlorine, bromine. Here, according to Davernier, if we take the arithmetic mean of the two elements, then that will be the atomic weight of the middle element. If we take the arithmetic mean of the atomic weight of the first and means upper and lower element, that will be the atomic weight of the middle element. and but this concept is not true for the elements having higher atomic weights. So that idea was made to be wrong. Next, if we take by this here, on the same way, there is Newland's law of octave. Newland's, Newlands, Newland's law of octave. According to John Newland, if elements are arranged in this way, in the increasing order of atomic weight, just like lithium, sodium, potassium, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium, etc. If elements are arranged in the increasing order of their atomic weight, then the properties of elements get repeated after the eighth element. Just like if we start this as the first element, its eighth element is sodium. Lithium 1, 2, 3, 4, 5, 6, 7, and its eighth element is here sodium. So the properties of lithium and sodium is found to be similar. This is same as just like we say sa, re, go, mo, po, do, ni, sa. In the musical scale, we can arrange it as sa, re, go, mo, po, do, ni, sa. So if we start, just like suppose if we start from boron as the first element, its eighth element is aluminum, like sa, re, go, mo, po, do, ni, sa. So the property of boron and aluminum is found to be similar. This is according to Newland's law of octaves. Now, so here we can see that different scientists, different chemists have arranged the elements in their own way to make the study of elements more easier and more systematic and scientific. Later on, it was Dmitry Mendeleev. Dmitry Mendeleev in 1869 AD, he arranged the elements in the increasing order of atomic weight or atomic masses. He showed that the properties of elements get repeated after a regular interval if elements are arranged in the increasing order of atomic weight, and Dmitry Mendeleev showed that if elements are arranged in the increasing order of their atomic weight, then the property of elements get repeated. It means that the fundamental property of elements is here taken in the increasing order of atomic weight of the elements. According to Dmitry Mendeleev, he had arranged the elements in the increasing order of atomic weight in 1869 AD. 1869 AD. And Dmitry Mendeleev gave a law. That law is called Mendeleev's periodic law, which states that this Mendeleev's periodic law states that physical and chemical properties of elements are the periodic functions of their atomic masses. Again, physical and chemical properties of elements are the periodic functions of their atomic masses. Here, periodic function word is used, or periodicity is used. Periodicity means to say the repetition in the property of elements after a certain regular interval of time. That term is called periodicity. Their property of elements get repeated in a regular interval of time when they are taken when elements are arranged in the increasing order of their atomic masses or atomic weights. But here, in the Mendeleev's periodic table, in the old form of Mendeleev's periodic table, there are 8 groups and 6 periods only. But later on, after their recovery, means when new elements were discovered in the new periodic table, elements have been added, more and more elements have been added there. Here, this Mendeleev's periodic table is a systematic arrangement of elements in the increasing order of atomic weight. In the old concept, in the old version of Mendeleev's periodic table, there were 8 groups and 6 periods only. There were only 63 elements discovered. Position of isotopes, position of hydrogen, lanthanides and actinides were not given. There were so many demerits in the periodic table also. So, just like here, we can say there are so many advantages of this table also. In the Mendeleev's periodic table, there are several advantages also. Just like it is the first systematic arrangement of elements, in the increasing order of atomic weight. Similarly, we can say that in the Mendeleev's periodic table, there were several vacant positions also. He left several gaps in the periodic table, gaps or vacant positions in the periodic table, so that new elements will be discovered in future and they would occupy those vacant positions. Just like he left several gaps by giving a star mark. Next, later on, in the same periodic table, those elements, those gaps were fulfilled by some elements like he took Ica aluminum, Ica boron, Ica silicon, Ica manganese, and after the discovery of new elements, those Ica words were replaced by Mendeleev himself. Similarly, Mendeleev's periodic table helps in the correction of doubtful atomic weight of some elements. The atomic weight of the elements like beryllium, platinum were found to be wrong in the previous periodic table. Here, Mendeleev corrected the atomic weight of such elements by a formula: atomic weight equal to equivalent weight into valency. There is one term to find formula of atomic weight. Atomic weight equal to equivalent weight into valency. By using this formula, Mendeleev corrected the atomic weight of the elements like beryllium and platinum. So, this Mendeleev's periodic table helps in the correction of doubtful atomic weight of some of the elements like beryllium, platinum, gold, silver, etc. Here, there are so many defects in the Mendeleev's periodic table. Before that, we want to know about isotopes. Isotopes means what? Iso means literally we can say iso means same, and tops means position. Tops means what we say? Position. Here, this is the literal meaning of isotopes. Just like hydrogen. Hydrogen has 3 isotopes. 1H1, 1H2, 1H1. Here, 1H2 and 1H3. 1H1, this is called protium. Protium, this is deuterium. And here is tritium. I mean to say that same element have different atomic masses. Atomic number is same, just like hydrogen has atomic number 1. But their atomic mass is different. This protium has atomic mass 1, deuterium 2, and tritium has atomic mass 3. So, I mean to say that isotopes are the atoms of the same element having same atomic number but different atomic masses. Isotopes have same atomic numbers but different atomic masses. You can say they are the atoms of the same element having same atomic number but different atomic masses. This is one of the most common examples of isotopes. Hydrogen has 3 isotopes, namely protium, deuterium, and tritium. Similarly, carbon C612, C613, and C614. Here, element is same, carbon, but their atomic masses are different. This is another example of isotopes. Likewise, the next term is isobars. Now, the next term is isobars. Isobars, they are atoms of the different elements. Atoms of different elements having same atomic masses. Here, we should know this property of isobar. That's like atomic number is different as atom is different, but the atomic mass is same here. So argon and calcium are examples of isobars. Likewise, there is one more term, lanthanides. Lanthanides. What do you mean by lanthanides? Lanthanides means the element after lanthanum. The 14 elements after lanthanum in the periodic table are called lanthanides. For example, we can see that here is the atomic number of lanthanum. We can say that is 57. This is 57. This is the lanthanum element lanthanum. And after that, element cerium is given. Cerium to this element is here, lutetium, means we can say that the 14 elements after lanthanum from atomic number 58 to 71, they are collectively known as lanthanides. Lanthanides means the 14 elements after lanthanum from atomic number 58 to 71, they are collectively known as lanthanides. We can say 58 to 71. Atomic number from 58 to 71, they are collectively known as lanthanides. Lanthanides means the 14 elements after lanthanum from atomic number 58 to 71, they are collectively known as lanthanides. Another is actinides, ACTINIDES. It is also called actinide series. This represents the elements from atomic number 90 to 103. 90 to 103 means here this is thorium and here is lawrencium Li. These are also 14 elements. So total lanthanides and actinides, there are total this will be 28, means 50 lanthanides and 14 actinides. So total will be 28. These lanthanides and actinides, they are kept at the bottom of the main body of the periodic table in modern periodic table. And next is, after that, Here we should know some terms in the periodic table. Some terms of the periodic table are here, just like what is meant by periodic table. Previously we have discussed about the periodic table. That is the tabular chart. It is a tabular form of elements which are arranged in the certain rule on the basis of similarities and dissimilarities. Elements are classified. Elements are arranged into different groups and periods. This tabular form, this tabular arrangement of elements to make their study easier and more scientific, this tabular chart is called a periodic table. In Mendel's periodic table, elements are arranged in the increasing order of atomic masses, whereas in the modern periodic table, elements are arranged in the increasing order of atomic numbers. Now, in this topic, just we see that first of all we should study about group. What is meant by group in the periodic table? Group. They are the vertical columns in the periodic table. These vertical columns of the periodic table, they are called groups. Similarly, they are, we can say, vertical columns. Vertical columns of the periodic table, of the periodic table. Periodic table are called groups. And periods means periods. They are horizontal rows. Horizontal rows of the periodic table. Horizontal rows of the periodic table, they are called periods. In the modern periodic table, there are 18 groups and 7 periods. 18 groups. These groups have been written in the Roman letters. They are written in Roman letters. These 18 groups are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. In this way, groups are arranged in vertical columns in the periodic table. And other period. Periods means horizontal rows of the periodic table. Horizontal rows, just like here, this is period 1. Period 2. Period 1 has only one element, hydrogen. Hydrogen, and here one other element is helium. Hydrogen and helium is 2 elements. In period 1, there are 2 elements. In group 1A, 1 hydrogen, and in group 0 it is helium. Elements of group 1A, they are called alkali metals. Elements of group 1A, they are collectively known as alkali metals. They are highly reactive elements. All these elements have only one valence electron. They are s block elements. In this group, hydrogen is non-metal and other elements are highly reactive metals. In group 0, elements which are inert, they do not take part in the chemical reaction. Such elements are taken. They have valency 0, or we can say they have no valency. Here, in this group, helium is s block element. Its electronic configuration is 1s2, means helium is s block element. But other elements, neon, argon, krypton, these elements are p block elements. Their last electron falling to p subshell. So they are in the same way. Elements of group 2A, they are beryllium, magnesium, calcium, strontium, barium, radium. These elements are the members of group 2A, and elements of group 2A, they are collectively known as alkaline earth metals. Alkaline earth metals. Elements of group 2A are called alkaline earth metals because they form hydroxides which are soluble in water and they are alkaline in nature. they form alkaline solution with water. Similarly, here the other elements of group 3b, 4b, 5b, 6b, 7b. In group 8, we can see that there are 3 columns, and these in this group it contains 3 columns, and in each group there are here iron, cobalt, nickel. This group, the properties are nearly similar, so they are placed together. In group 1b, it contains coinage metals, copper, silver, gold. They are known as coinage metals. Coinage metals refers to the sense that they are used to make coins and jewelries. So elements of group 1b, they are coinage metals. These 3: copper, silver, and gold. Now we study about group 6a. Elements of group 6a, they are called chalcogenous. Chalcogenous because they are chalcos means here copper, and genus means to produce here. Actually, these elements are highly reactive with copper. They react with copper, so they are called chalcogenous. And elements of group 7a, they are fluorine, chlorine, bromine, iodine, acetine. In this way, elements of group 7a, they are called halogens. What we call that? Halogens. Halos means group 7a. In group 7a, they are called halogens. Halos means salt, and genus to produce. They react with metal to form respective salts, just like sodium reacts with chlorine, then it forms sodium chloride. This is a salt. So means to say that they produce salt with metals. Therefore, we can say that they are the elements of group 7a. These elements are highly reactive nonmetals. Elements of group 1a are highly reactive alkali metals, except hydrogen. Hydrogen is here nonmetal. But elements belonging to group 7a, they are highly reactive nonmetals. All these elements have 7 valence electrons, and they require only 1 electron to complete their octets. Fluorine has electronic configuration just like fluorine. The electronic configuration of fluorine is 1s2, 2s2, 2p5. It means that it has 7 valence electron. 7 valence electron. All these elements of this group 7a have 7 valence electrons, and they require only 1 electron to complete their octet. So they are highly reactive nonmetals. They have the tendency of gaining of electron, accepting electrons. And here, these people of element in the next topic, in the next day, in the next class, I will teach you about this electronic configuration also, how it is p block element and why it is kept in p block. As chlorine, here the last electron of fluorine falls in p subcell, therefore it is kept in p group p block in this table. Now, elements of group 0. Elements of this group 0, they are inert elements. They are group 0. They are called inert elements. They are not reactive. They are these elements belonging to group 0, do not take part in the chemical reaction. They complete either duplet or octet. Element helium completes duplet and it is chemically inert. Element neon, argon, krypton, xenon, radon. These elements have 8 electrons in their valence shell, so they are chemically inert and they do not take part in chemical reaction, and they are kept in the 0 group, or we can say group 18. They are placed to the extremely right side of the modern periodic table. In the modern periodic table, they are kept to the extremely right side. Now, here, after knowing group, period, alkali metals, alkaline earth metals, isotopes, isobars, lanthanides, and actinides, we go now again systematically through Mendeleev's periodic table. First of all, what is Mendeleev's periodic table? I have already discussed that it was Dmitry Mendeleev who had arranged the elements in the increasing order of atomic weight. He took the fundamental property of element, atomic weight, and systematically he had arranged the known elements at that time in the increasing order of atomic weight. That tabular form, that tabular arrangement of element is called Mendeleev's periodic table. And in that periodic table, though there were several demerits in that table here, just like position of hydrogen was controversy, position of isotopes were not given. In some places, elements with higher atomic weights were given before the elements with lower atomic weights. Some chemically similar elements are separated. So there are so many such type of demerits, drawbacks, or limitations, or we can say disadvantages in that table. So this table is not in wide use these days, and these days we study in detail about modern periodic table, which is given in our syllabus also. Now, first of all, what is the statement of Mendeleev's periodic law? What is Mendeleev's periodic law? What does it state? What is the law of given by Dmitry Mendeleev? This states that Mendeleev's periodic law states that physical and chemical properties of the elements are the periodic functions of their atomic masses. Periodic function given here, periodic function of their atomic masses. What does it mean? This periodic function means repetition in the properties of elements after regular interval of time. When elements are arranged in the increasing order of atomic weight or atomic masses, then the property of elements get repeated according to Dmitry Mendeleev. That's why this word periodic function, or can say periodicity, can be used here. So this states that physical and chemical properties of elements are the periodic functions of their atomic masses. You can remember this, and for class 10, this point is very, very important. Most of the time, this law is being asked. State Mendeleev's periodic law. So we can remember in the same way. It states that physical and chemical properties of elements are the periodic functions of their atomic masses. Dear students, in the next stage, I will teach you in detail about Mendeleev's periodic table. So today, some homeworks are given to you to do in your copy for the next day. HW homework. What is group? What is group? Define period. Define period. 3 number. States Mendeleev's periodic law. 4 number. What is periodic table? What is periodic table? Define isotopes. Define isotopes and isobars. What is alkali metal? Alkali metal. Give examples. Give examples. Similarly, define halogens. Halogens. In which group they are placed. In which group they are placed? In the periodic table. 8th number. State what is alkaline earth metal. Alkaline earth metal. Give examples. Give examples. Next is 9th number. What is periodicity? What is periodicity? And 10th number, define coinage metals. Coinage metals. Give examples. In this way, by studying this topic, students can do this homework, and in the next day, I will teach you. I will first of all explain about these terms, and then I will explain you about Mendeleev's periodic table in detail. Thank you.